Today in class, we talked about a specific type of rotation that involves rotating points or lines or images 180 degrees. Now, one thing I want to point out is we talked about using algebraic reasoning where a point AB changed to point negative A, negative B. Now, we cannot use this rule right now because in order for that rule to work, our center of rotation has to be at the origin. And as you can see, in this example, it looks like our center of rotation is here. So please do not be confused by this, and please do not try to use the method by using the opposite of the coordinate pairs for this one. But let's take a look at what we are going to do. We want to see if certain line segments are parallel. So we can see that BC will be parallel to B prime C prime because they both exist on horizontal grid lines. And in the same fashion, AB will be parallel to A prime B prime because they both exist on vertical grid lines. But how can we prove that AC and A prime C prime are parallel? Well, if you remember, we can use patty paper to verify if segments are parallel or not. So if you have patty paper or tracing paper, what you're going to do is try to line it up. And then we will draw our lines like so. And that one's a little bit off, but you'll get the idea. And I'm going to go ahead and group this all together. And then what we should be able to do is rotate this, and you should be able to see that one set of lines flips. My center was off a little bit, but you can see that one set of lines can flip all the way onto the other, and they will be parallel. So what other questions do we need to answer? Well, they want us to connect B and B prime. So if you follow this dotted line, that's B to B prime, and C to C prime, like so, and then A to A prime. And what do we notice when we connect all those lines? Well, we notice that they're all intersecting at one point. And so what do we think that point would be? Well, this one point would be the center of rotation. And if we wanted to identify the coordinates of that point, if we start at the origin and go over 2 and up 1, 2, 3, 4, 5, 6, we would have the point 2, 6 as our center of rotation. So the last thing that they might ask you to do is, well, what happened if a triangle ABC could rotate and become A prime, B prime, C prime? Well, once again, we need to, if we're going to say that this can be rotated onto another image, we have to be able to define what a rotation is. So if they're asking if it can be rotated, we need to be able to say what the center of rotation is and the degree of rotation, okay? So let's get this patty paper out again, and we'll try to see if we can do a slightly better job of lining it up with the center, and that would make it better. So maybe something kind of like that. And if I go ahead and take this triangle, and hopefully, let's go ahead and group these together, and we're going to rotate them. And in order for this to end up at the other spot, it looks like that would be 90 degrees. And once again, my center's off just a little bit. I apologize for that. But that would be 180 degrees, okay? And so we're able to see that we did 180 degrees, and we did that 180 degrees in a counterclockwise direction, which is why the 180 degrees is, in fact, a positive 180 degrees. The other thing to remember is that the center of rotation, which we have to identify, was in fact the 0.26. So hopefully this is helpful and will give you some hints as far as getting the homework done tonight. Thank you for watching Mr. Hatton's YouTube channel.